Okay, this is an example of a solar kettle. What I've got here is an evacuated tube, very similar to a vacuum flask, that you've got a double layer of glass with a vacuum in between them. The inner layer of glass is coated with a special material which absorbs the heat, and as the sun moves around throughout the day, it's constantly facing the sun, and that heats up the water, which is basically sitting in a vacuum place. What I've done slightly differently here is that I've put a copper pipe which feeds all the way to the bottom. That means if I pour in cold water, the cold water will go right to the bottom, and because hot water always rises, the hottest water will be at the top. And I've made a short spout here which goes into the top section, and the water we poured in the top part here, and this is an empty vacuum flask. So as I pour in the cold water, the heated water comes out the top. Now bear in mind, this isn't an instant heater. It has been heating up slowly throughout the day. Now today is very close to Midwinter's Day in Cape Town, and it has already heated the water to boiling point once. It obviously doesn't happen every day, but that is possible. So from an energy efficiency point of view, an energy efficient house that captures its heat that it's going to be using for cooking or for drinking later is able to capture it for free and then store it in another vacuum flask for free. These evacuated tubes are extremely common on low pressure solar water heaters, which have been installed all over South Africa in the last 5 years. I can't give you the exact replacement cost, but you'd be looking at under 200 Rand, I'm sure. So what this has done is effectively taken 2 liters of cold water, it's turned it into 2 liters of nearly boiling water, which means that any extra energy you need to add to it will be minuscule compared with the overall free energy received. Okay, so that's effectively a 2 liter gain of free solar heated water.